Hi everybody, I'm Dr. Haritha. Today I'm going to explain you searching technique, a new searching technique other than your earlier linear search, which has a logarithmic amount of time complexity that is called as binary search. Binary search is really a beautiful searching technique in terms of time consumption when compared with your so-called earlier linear search, wherein you compare. What do you mean by searching? Searching is seeking for something. Suppose you have a list of student numbers. I would like to find out whether some number x is available in the given list or not. That is nothing but searching. Seeking for something in the given list, whether it could be an integer or a character or a float or a string list. No matter what the type of the input data is, you need to seek for something, some value in the stored data items. So in your earlier linear search, what happens is you compare the element to be found with all the elements in the given list. Let us suppose if your input is an array of integers, array of 100 integers, and some k value need to be found whether it is existing in the 100 element list or not. So you have to start with the first number and compare each and every number until it is found or you reach the end of the list. That is the basic concept of your linear search. What happens if your element is at nth position, that is the last position? It will take n searches. Imagine if n is 10 power 9, the size of your array is 10 power 9. The CPU has to perform 10 power 9 searches, which is very time consuming. Your CPU time is very precious. Students, always the time and space of your machine are very precious. They demand the cost of your machine. Intent demands the cost of the total application. Therefore, binary search is one of the best available solution to search the given value in logarithmic amounts of time. Then how does it work? How it reduces the time taken by your searching algorithm is, and here the most important constraint, unlike your linear search with binary search, is the input must be sorted. Remember, always your input must be sorted before you fed that input to your binary search algorithm. That is the constraint, otherwise you won't get the actual results, right? So what is the procedure here in your binary search algorithm is, instead of comparing each and every element starting from the first element till the end, or you found the element to be found is found, here you always compare the element with a special element. Got it? What is that special element? Who decides that he is the special key to be compared? Instead of comparing with all, you find a specific key and you compare with that, like a Spock, right? It's like a delegation of authority. How you do? Suppose in an organization, highest position is some president, right? So president need not individually convey his message to all the members of your organization. Simply he delegate the message to the next level people, and they share to the next level, they share to the next level, and in turn the message passes. Here, what is the element to be compared is, you may wonder, instead of comparing with each and every element, how can you find whether this is available in the list or not? How can you finish your searching by comparing with only one value? And what is that value? Students, it is nothing but your middle value. Since the input array or input list is sorted, find the mid and always compare the element to be found with the middle value. If the element to be found is less than the middle value, ignore the rest of the values for further comparisons. That is, every time you are trying to eliminate half of your input for searching. Do you understand? That is, if the element is less than middle value, ignore all the values from middle to the end. Only consider the first to mid. Mid minus 1, first to mid minus 1, middles are not required. And repeat your searching process over this. What happens if your element is greater than mid? Yes, ignore all the values from starting point to middle. For the next iteration to be for your searching process, takes only the values from mid plus 1 to end of the array. That means every condition check, every search, every single search will reduce your input size by 2. Will reduce your input size by 2, thus reducing the time taken to logarithmic times rather than linear times in your linear search. You repeat this process until the element is found. Yes, I'll explain with this with a simple example. See here, this is an array of size 5. The elements are 1, 2, 7, 12, 34. Remember students, your input must be sorted. Good. Your input must be sorted. Yes. And you know that all your this are addressed using a relative addressing, that is an offset. In C language, your array offset starts with 0 and ends with n minus 1. Since the size of array is 5, it starts at 0 and ends at 4. A of 0 holds first value, second value, and so on. A of n minus 1 holds the last value of your array. Right. Now how to find the middle value? How to find this mid? So let us name the boundaries to be first and last, and you have to find out the mid. How to find the mid? What is the formula to find the mid, guys? First plus last by 2. First plus last by 2. So therefore, what is that first value? 0 plus 4 by 2. How much it is? 4 by 2 is 2. Now your mid is 2 and A of mid is how much? The value at position 2 is 7. That's why here I am accessing. The element to be found is called as key, and the key is 12 in this example. I will compare 12 with A of mid, that is my middle value. What is A of mid? 7. Is 12 is less than 7? The condition is false. If 12 is equal to 7, the condition is false. If 12 is greater than 7, yes. What I have to do? If 12 is the element to be found is greater than middle value, I have to ignore all the values from first to mid and consider my first to be mid plus 1. What is mid plus 1? 3. Mid is 2. So, I have to set first is equal to mid plus 1. If the key is greater than middle value, I have to change the first to be mid plus 1 if k greater than a of mid. Right? Now once again you repeat the process on the array. Always array boundaries are from first to last. Now your array is this. Alright. Then you calculate once again mid. What is mid now? Mid is equal to, what is the value of first? 3. Last is 4. 3 plus 4 by 2. 7 by 2 is integer division 3. So this is how your mid and first are pointing to 12. And is key is equal to mid? A of mid? Yes. The element is found. The element is found. Understood? Yes? Yes, I'll explain with one more example here. Let me explain this. Excellent. Right? So what is the size of the array here, guys? 10. The size of the input array is 10. And the element to be found is 23. And always remember, for binary search, the input must be sorted. That is the constraint you always need to remember. Either you run a sorting algorithm before you run your binary search algorithm, or you give the sorted input at the input terminal. The array size is 10, therefore your offset ranges from 0 to 9. See here, your offset value a of 0, 0 to 9. So your first, here in this example they are using first means L, or you can write this first. This is first and this is last. Your first is 0 and last is 9 now. Then start finding middle. What is the value of middle? First plus last by 2, that is 0 plus 9 by 2. How much it is? 9 by 2. Integer division 4. So middle is your 4. Compare with, in the first iteration, compare your target value to be found, that is 23, with 16. Is 23 is less than 16? No. Is 23 is greater than 16? Yes. 23 is greater than 16. So ignore first half of the input and change your first to be mid plus 1. Only first will be changed if the target is greater than a of mid. So now see here, this will become your first and this is your last for the next iteration. Remember students, the procedure is same. Always find the mid, compare the middle value with your key to be found. If middle value is less than key, change the first to be middle plus 1. If the middle value is greater than key, change the last to be mid minus 1. Change, this is the only condition you need to remember. If key is greater than a of mid, first equal to mid plus 1. Else, if key is less than a of mid, last equal to mid minus 1. Else means, see, if it is not greater than, not less than means it is equal, it is found case. Only these three are the conditions. If it is greater than, change the first to be mid plus 1. If it is less than, change the last to be mid minus 1, otherwise it is found. If it is not greater than, not less than means obviously there is no option, it is found. Very simple logic. Understood? Yes. Right. Now we move on to our second iteration. Now once again in this second iteration you have to find out the middle. What is the middle? First plus last. What is first? 5. Last is 9. What is 5 plus 9 by 2? 7. 14 by 2, that is 7. Now this is your mid, guys. This is your mid. All right. Yes. Now you compare your 23 with mid. Is 23 is greater than 56? No. Is 23 is less than 56? Yes. Then ignore from mid to last. Observe here, every time you are eliminating half of your input, half of your current input for searching process. Already this is eliminated in the first iteration, and now you have eliminated. What is left here? You have to change the last to be mid minus 1, and this is obviously your first. And then for this iteration, calculate mid. Mid is equal to last plus first by 2, that is 5 plus 6 by 2, 11 by 2, that is 5. What is here 5? 23. Compare 23 with 23. Yes, it is found. It is found. See how beautifully you are in the successful state. Right? For this, how many searches you have made? One search with 16, one search with 56, and 23rd is with another. That is, you require only 3 searches. But if you take linear search, how many searches hardly you have to perform? 2, 5, 8, 12, 16 and 23rd. 6 searches. 6th is your hit search. That is how it reduces the time taken by your algorithm. Every time it finds the mid, the simple formula to find the mid is first plus last by 2. It finds the mid and only compares the value with mid. If the target is less than mid value, eliminate mid to last for further search process. If the target is greater than mid, eliminate the first mid values. Repeat the process until you found. Understood? Any doubts? Yes. This is the algorithm what I have discussed. So repeat the process until low is less than high. That is the condition whenever you work with the divide and conquer strategies. Always this is one of the best example for your divide and conquer strategy. You divide the input and search, divide the input and search, divide the input and search. You are dividing equally here by finding the middle value. Always all the divide and conquer strategies, the terminating, when I have to terminate this process, that is finding the mid and comparing with the key and proceeding further, when I have to stop this, that I have to perform repeatedly until I found out there is no element existing. When I have to finish this is, always the condition is your low must always be less than high. Whenever your low crosses high, you are at the end of your iterations. Find the mid. Mid is equal to low plus high by 2 here, and then if x is equal to as it is found, otherwise if x is the element to be found here greater than middle value, set the low to mid plus 1, otherwise set the high to mid minus 1. Whatever I have discussed till now is replicated here. Find the mid, compare with middle value. If it is equal to, return it is found, otherwise if it is greater than, set the low, otherwise set the high values. Yes. All right. So these are few self-assessment questions you can go through, and these are further references for you if you have any doubts, further references of with respect to the books and links. And that's all for today. Thank you so much.